If you give me permission to move ahead, if you say there are no doubts, I am moving to the next part of the breathing and gaseous exchange. Okay, so let's begin today's class. Now, today we'll be learning about respiratory volumes and capacities. What? Respiratory volumes and capacity. You should know this, a very important for your MCQ, for your what? Yeah, for MCQ papers for NEET exam. So, what do you mean by volumes? Volume means volume. When I talk about volume, volume means where volume of volume of air in lungs can hold. Volume of air a lungs can hold. Okay. What is capacity? Capacity is a sum of two or more respiratory volumes that is the capacity. Understood the difference between the volumes and the capacity? How do you estimate the volume of the air? Volume of the air is estimated by a spirometer. By a spirometer. Spirometer tells you your working capacity of your lungs. Nowadays, COVID patients are being checked on the spirometer to know how well the lungs are working, how well the lungs have capability of holding the gas, holding the air. So this is about the spirometer. Is it clear? Now, in this we'll be studying a few very important terms. This is how the spirometers works initially, but now you get through if you have seen, it's just a one small clutch which is fitted. So that will tell you this about the spiro saturation level of oxygen in your body. So this is how the patients used to blow the air into this through the mouth, and this tells you how well your this graph which is coming will tell you how well your lungs is working. Now, very important now, we are coming to a point which are very important terms. First, we'll discuss about the volumes. Each and everybody will concentrate. I'll give you time to write down. Inspiratory reserved volume or IRV. IRV. What is IRV? Before getting into IRV, let us talk about tidal volume. TD is tidal volume. What? TD is tidal volume. So what is tidal volume, my dear students? Tidal volume is an amount of air inhaled and exhaled. You can see the amount of air inhaled, the amount of air exhaled. That is called tidal volume. Means what? Let me write down here. I have this. Yeah. What is tidal volume? It is amount of air inhaled or exhaled during normal breathing. During, can you all see the screen? Hello, are you all there?
Yes, man, we can see.
Yes.
Next. Are you done with this statement? Next. So how much is it? 500 ml. This count is important. You should remember this count. 500 ml is a volume of tidal volume. Its value is 500 ml for a normal healthy individual. Did you understand tidal volume? Next. Next is inspiratory reserve volume. Means what? This is again tidal volume. Here means volume of air a person can inhale by forceful more than what is required. Forcefully more than what is required. Requirement is until here, but more than what is required is been inhaled. This part, extra part, more than what is been is inhaled. That is called inspiratory reserve volume. How much? 300 ml. So when you want to write down volume of air, write down volume of air a person inhale by forcible inspiration over tidal volume. Done? Everybody understood what is IRV? Yes? Yes or no?
Ma'am,
Yeah.
which definition is that? Forcible inspiration.
This is the definition for IRV. IRV.
Full form.
Ma'am, please
Full
show
form
the
is
previous slide.
full form is given. Inspiratory reserve volume. Can you all see
Thank you.
the slide? Sanjana, what is this?
No, ma'am, it's by mistake. Sorry.
Huh? What happened, Sanjana?
Ma'am, it was by mistake.
Okay. Concentrate in the class, my dear. You need to concentrate in the class. Not working on other side of the team. 3000. The volume is 3000.
Ma'am,
Mm-hmm.
ma'am, what is the 3500 ml in the other column?
Do not write the other column. When I have not explained you, do not write the other column.
Okay,
Go
sorry,
one
ma'am.
by one. Now I have explained you TD and now I have explained you IRV. My question is TD and IRV is clear to all.
Yes, ma'am.
Can we move to the
Ma'am,
next?
please show the
Next.
definition for TD.
TD. Okay. Check. It's an amount of air inhale or exhale during normal breathing. Done? Now next.
Done, ma'am.
Now next. We are done with TD, we are done with IRV. Now we are going to ERV. ERV or expiratory reserved volume. Expiratory reserved volume means what? Let me write down and then I explain you. Write down respiratory ERV. It is amount. It is the amount of air required over tidal volume by most forceful inspiration. Its value is value is 1000 to 1100 ml. When? What do you mean? More than what is required. Tidal matlab kya hai? Normal. Inhale, exhale. But when it is more than what you need to exhale, that is called ERV. When you exhale more than what is when you inhale what is required more than the tidal volume, that is called IRV. IRV is 3000 and ERV is around 1100. For normal healthy adult, the volumes. Then this is, you can see now this is normal inhalation. When it is come after the forceful, this is more than what is required. This is called again ERV, right? Did you understand? Now, what is RV? What is RV? RV is important, my dear students. RV is important. What is RV? Let's write down here. RV. RV, yes, reserve volume. RV is residual volume. Residual volume. It is an amount. It is the amount of air that remains inside lungs after forceful exhalation which is equal to 12. Yeah, reserve volume or residual volume. But remember, as most of the time it's they ask you as reserved residual volume. Residual volume is that volume After your forceful, are you done with the writing? After forceful exhalation, how much ever you want to exhale forcefully out of the lungs, but still some of the air is present in the alveoli, and that volume is 1200. Any doubts to anyone until here? So whatever the air that is present is being exhaled out, but still some of the air is remaining in the alveoli. That is called residual volume. Is this point clear? Next, this is all about the volumes. Now, what about the capacities? The different capacities. Okay, capacity is what? Sum of two or more reserve volume, which is it can be any pulmonary reserve volumes. It can be any of them. So those are said to be capacity. Ma'am, is this same volume which is removed during ERV? ERV, the volume that is removed is 1100. In residual, it will be 1200 ml of volume which remains. Next, now forget about volumes. I hope volumes are clear. Now we are coming to IC. We are coming to IC, that is capacities. Capacities क्या है? Sum. So capacities is equal to IC, which is inspiratory capacity, which is what is inspiratory capacity? Inspiratory capacity is IRV plus TD. So when you add 3000 plus 500, the ml, the capacity becomes 3500. What is IRV? What is IC? IC is equal to IRV plus ITD. Clear? What
Ma'am,
is
I see inspiration capacity.
IC is inspiratory capacity. It's given. Okay. Now, whatever the IRV IC is left, that becomes a functional residue. Functional residue is ERV. Functional residue is ERV plus RV. Functional residue. What is EC? EC is expiratory capacity. EC is equal to TD plus ERV. What is vital capacity? Vital capacity is equal to IRV plus TD plus ERV. What is total lung capacity? TL is total lung capacity. total lung capacity. How much? So TLC is equal to, see, you will understand. Wait. TLC is equal to
Ma'am, explain
IRV.
EC again.
IRV, I'll explain you. TD. Okay. Let me do it in other slide. Okay. Let me do it in other slide. I'll explain you. I'm writing it down here. Write down IC, which is inspiratory capacity, which is equal to IRV plus TD. You know what is IRV, you know what is TD. IRV is how much? 300 plus 500 ml, which is equal to 3500 ml. Nothing while I'm talking about the inspiratory and the volumes and the capacities. Next, functional residual. You write down this table and then I'll explain. Capacity, which is equal to FC, which is FC or FR. You can take it. FRC. FR. FRC. Okay. Which is equal to ERV plus RV. ERV is how much? 1100 plus 1200 is equal to how much? 2300 ml. Next, vital capacity. This is VC, which is equal to, it's very important to know this term. Many questions will come. They'll ask you, IC capacity is how much? VC capacity is how much? A very important. What is a, you should know what is your lung capacity to hold the air, right? You should know some normal range. For any breathing problem, this everything is been calculated using a spirometer. Without lungs, you cannot breathe. If you do not breathe, you cannot survive. I'll tell you about 2 minutes. Vital capacity VC, which is, I had already taken the class. You were not there for the class. Abide. IRV plus TD plus ERV. IRV is how much? 300, 3000, 5, and then ERV is 11. So how much is the total? 480, 4800 ml. Now, total lung capacity. That is TLC. TLC, IRV plus TD plus ERV plus residual volume, which is equal to, you know, this is 4800 ml plus RV. RV is how much? 1200 ml, which is equal to 600 ml or 6000 ml is the total volume capacity of the lungs. Write down. Next, what is IRV? IRV is inspiratory reserve volume, which is equal to How much? 300 3000 ml. What is tidal?
Excuse me, ma'am.
Hmm.
Ma'am, vital capacity should be 4,600, right?
4600 yen. Then it should be 4600 to 4800 approximately. You can consider 4600 or 4000 to 800 approximately. Okay, numbers can change approximately. 100 200 ml doesn't matter.
Okay, ma'am.
Tidal volume, which is around 500 ml. Next, expiratory reserve volume. It's gone. Oh god. To write it again. Have you all done with the writing? Yes or no?
No, ma'am.
Anybody has screenshot of this?
Can you just go back to previous slide? What you have written?
Just a minute, just a minute. Please mute yourself. I told you if you have any queries, text me. Don't unmute. Is anybody have taken the screenshot of the previous slide? No?
Yes, ma'am. I think I've put it on the group.
You have put it in the group? Yeah. Just check with that. Let me cover this volume. TV is tidal volume. I am writing it this again because I missed that part. It got erased. Tidal volume, which is equal to how much? 500 ml. Then there is IRV, which is nothing but inspiratory reserve volume, which is equal to. Let me know if it's not helpful. I'll write it down again. 300, 3000. Then you have ERV, which is expiratory reserve volume, 1100 ml. Then RV, which is residual volumes, which is 1200 ml. Okay, then this all are volumes. This all are volumes. Now we'll discuss the capacities or capacity. IC is equal to IRV plus TB. Then FRC is equal to ERV plus TB. VC is equal to IRV plus TB plus ERV. TLC is equal to IRV plus TV plus ERV plus RV. Simple. Done writing this? Do tell me. I'll be waiting for you. Tanmay, why it's so strange? It's easy. Because you're learning for the first time, you find it something. Expiratory capacity, yes. Expiratory capacity, no. You have to know the functional residual capacity. You should know the functional residual capacity and expiratory capacity. Haven't given. Okay, let me write down expiratory capacity. Expiratory capacity is equal to TD plus ERV.
Done, ma'am.
RV. This is, do the correction. This is RV. Done. This have you all written in a notebook? Tell me now. Everybody have done writing on the notebook. There's somebody who has written very nice. It's Amod, right? Yeah, he has written very good. Yes. Yes, done. Others, are you done writing? Quick, quick.
Just a second, ma'am.
Yes, ma'am. Done.
Okay, fine. Now, just he told me to wait for a second. Somebody has told. Let us wait for a second. Everybody look to this and then look into the diagram. Let us move. I'm moving from here. Now, see this. Now see this diagram. What is tidal? Listen to this, everybody. Then you are going to write. Volume, you understood. Volume of air lungs can hold. What is capacity? Sum of this volume. Sum of these two volumes, that is called capacity. Sum means what? Addition, right? Tidal volume means normal inhalation, normal exhalation. Normal inhalation, normal exhalation. What is IRV? Normal inhalation, but more than that is required, we do extra. That is called in IRV, that is inspiratory reserve volume. Now, what is ERV? Normal inhalation, normal exhalation, but more than what is required, you exhale out. That is called ERV. Clear? In the lungs, you think about exhaling what is required, how much ever force you put and exhale out the air completely, but still 1200 ml of air will remain inside, and that is called residual volume. This is all about the volumes. Now, when we want to discuss about the capacity, there are 1 capacity, 2 capacity, 3 capacity, 4 capacity, and 5 capacity. Capacity of the lung to inhale is 3500. Capacity of lung to exhale is 1200. After the inhalation, the functional residue that is left in the lungs is 2300. Addition of this and this. Then
Ma'am, could you
vital.
please explain last statement you said just now?
Sorry.
Could you please explain again?
From where do you want me to explain?
After the 5 capacities.
After the 5, okay. Inhalation or in inspiratory capacity volume means what? This is A, this is B, this is C, and this is D column. Inhalation capacity is A plus B. So I have drawn an arrow from here to here, which give you, matlab, inhalation is a capacity of the lung, how much a lung can take in the air. The leftover part, that is C plus D, is nothing but C plus D is functional residual volume. When you add 1100 and 1200, the volume will be 2300, right? So this is a functional residual volume. What is EC? EC is B plus C. B plus C will give EC, the capacity of a lungs to exhale the air outside. That is 1600. Now, vital capacity is a combination of A plus B plus C, other than this residual volume. Residual volume is not included in the vital capacity. For the living, vital means for the life. How much is required? A plus B plus C is required. Then, total lung capacity. What is the total lung capacity? A plus B plus C plus D. All this, when you add together, this is the total lung capacity that your lungs can hold. Understood? Now I'll give you some time, each and every one. 2 minutes I'll give you. Please revise the table. It's the same table. Do not revise this. This will be more easy. Revise the table with the content you have written. I'll give you 2 minutes. If you have doubts, please text me. I'll give you 2 minutes. If anybody has doubts, please text me. I'm giving you 1 to 2 minutes just to revise the volumes and the capacity. If you say yes, then only I'm moving ahead. See, VCB, VC you can write it down as, see, 100 to 100 ml will doesn't affect. You can write it as for 4600 also. See, if you're done, say ma'am. If you have got that, say yes. If you have not still understood, you can send me your doubt. You can chat with me to clear your doubt. But I want you all to know this very important part. Okay, Rishikesh got it. Others, it's very easy. It's just because first time you're listening to this, it might take time, but it's very easy. And Sakshi has got it. Okay, good.
Ma'am,
Yeah, tell me.
could you please explain me the residual volume part again?
See, who is this?
Ma'am Sanjana.
Sanjana, listen. Residual volume matlab after you exhale completely, after the lungs have exhaled completely, whatever your capacity, forcefully you have exhaled the air out, but still lungs are never left empty. There is some air that is present. that is not under your control to exhale it. You cannot exhale it. That volume that is present inside after you are trying your best to remove the air from the lungs, that remaining is called residual volume.
Okay, ma'am. Thank you, ma'am.
You're welcome. Is anybody else any doubts? Can we move to the next if there are no doubts?
Yes, ma'am.
Now, very important point we are coming. So now, okay, before we move, let me tell you a few things. See, now there might be a question about this. What is dead space volume? If this is an alveoli, consider around 500 ml is reaching to the, after we inhale, you know where is alveoli present, around 500 ml is reaching to this alveoli. Okay, and now when it is reaching to the alveoli here cavity, it reach around 350 ml. Out of 500, 150 will not reach. 150 will remain here in the alveolar duct. Alveolar duct. This, the remaining 150 volume that is remaining in the alveolar duct, the air that doesn't reach to the alveolar cells that remain in the duct, that is called as dead space volume. Clear? That is called as dead space volume. Got the point? What is dead space volume? If 500 ml is reaching to the alveoli, out of 500, only 350 will reach to the lower side. This is blood vessels, right? This is lungs. So, the 150 that remains in the duct, that is called dead space volume. Okay, next we'll move. Exchange of gases. Exchange of gases, main thing. Exchange of gases, this is lungs. Okay? This is lung. And lung is, for example, this is an alveoli. You know, alveoli is surrounded by too many of blood vessels. Do you agree with me? No, it is inhaled gas only. Amor, that is inhaled gas only. But dead space volume is the volume, it is entering the lung, but it is not entering to the site of exchange. That is in the alveoli cells. You just have to know what is dead space volume here. Okay. Yes, it is present in the duct of alveoli. Whatever you inhale, it will not reach at the site of exchange. You know site of exchange? Do you remember we have drawn one diagram like this? If you remember the barrier diagram, alveoli, space, and blood vessels. Do you remember this diagram? Look into your books. You can open your books and check. So, here, what happened? This exchange that takes place from here to here, right? The exchange that takes place from here to here is by simple diffusion. So now we are studying this part. How is this exchange takes place? It takes place by simple diffusion. How do you think the exchange takes place? The exchange takes place by a partial pressure, due to partial pressure. Why it should require okay, oxygen needs to move from alveoli into the blood. Why carbon dioxide need to move from blood to alveoli? Who will tell whom? So this happens due to partial pressure. The movement of gas happens due to partial pressure. I'll tell you what is partial pressure. So what do you mean by partial pressure? Partial pressure is a pressure exerted by individual gas in a mixture of gas. Means you have oxygen, you have carbon dioxide, you have nitrogen, you have any other gases. Each gas has its own partial pressure. Own partial pressure. If for the partial pressure of gas is 3, if the partial pressure of gas is 2, if the partial pressure of nitrogen is 1. So, on this will decide the movement of gases. From higher partial pressure to the lower partial pressure, the movement of gases takes place from higher partial pressure to lower partial pressure. Are you understanding? Movement of gas, we always speak the blood circulatory system helpful to carry gases, to bring out the gases, lungs involved in exchange of gases. How does this happening? This all is happening due to a partial pressure of each gas. Are you understanding? Partial pressure is pressure exerted by individual gas in a mixture of gas. Write down this. Now, partial pressure for oxygen is represented by PO2, and for carbon dioxide is PCO2. This is how you represent the partial pressure. Next, let us draw this diagram, and it will make you easy. And this is an important diagram. Everybody will draw along with me. Done? Do tell me once done. It's very easy, very easy.
Done, ma'am.
Okay. So now listen. Everybody done, right? Now listen. This is alveoli. This is blood circulation. And this is tissue, right? Now what happened? Listen to this. The first thing you should know is the exchange is happening by simple diffusion. This we have learned. Simple diffusion. The exchange is due to simple diffusion. How do they move? And they move from high partial pressure to low partial pressure. You should know this. From high partial pressure to low partial pressure. The gases move from high partial pressure to low partial pressure is an important statement. Now, the atmospheric air of oxygen is 159 mmHg. The unit is mmHg. Partial pressure of oxygen is 159 mmHg. The partial pressure of carbon dioxide is how much? 0.3 mmHg in the atmosphere. This is in the atmosphere. Everybody will listen. I'll give you time to understand and write later. Everybody will just listen. Atmospheric air kitna hai? 0.3 carbon dioxide and oxygen 159. When you inhale the gas by the air, by the time it reaches to the alveoli, the atmospheric or alveoli, the partial pressure of oxygen is 104 mmHg and carbon dioxide will become how much? 40 mmHg by the time it reaches to the alveoli. You know the alveoli is surrounded by blood vessels, right? They're surrounded by blood vessels. So when, okay, this is one part. Now, you have heart which is right side and left side. Left side heart always receive what kind of blood? Who will answer me? Quickly text me. Left side of the heart receive what kind of blood? Oxygenated or deoxygenated?
Oxygenated.
Very good. Oxygenated. Left side of the heart always receive oxygenated. Who brings the oxygenated blood to the left side of the heart? Pulmonary vein. Who brings? Pulmonary vein brings the oxygenated blood. Pulmonary vein is coming from the lungs. We'll study this in circulatory system. But remember, pulmonary brings oxygenated blood. Who gives oxygenated blood to different parts of the body? Who give oxygenated blood to different parts of the body? Aorta. Very good, Madhura. It's aorta, right? It gives oxygenated blood to different part of body. Now, right side of the heart receive what kind of blood? Right side of the heart receive what kind of blood? Deoxygenated. Very good. Deoxygenated. Right side will receive deoxygenated. Now this deoxygenated blood gets into the heart right side by vena cavas. By what? Vena cava. Superior vena cava, inferior vena cava will discuss. Who brings the deoxygenated blood from the body to the heart is the vena cava. The superior, inferior will study later. Okay. Now you just remember vena cava. Now The right side has received the deoxygenated blood. It has to go to the lungs. Now this blood which is deoxygenated need to go to the lungs. Who carry this to the lungs? Who carry the deoxygenated to the lungs? Pulmonary artery. Very nice. You know this. Very good. Pulmonary artery. Right? Now, so now what happened? The right side, remember the right side is having deoxygenated. I have shown you in the blue color. The blood in the blue is deoxygenated. So pulmonary artery carries this blue deoxygenated blood to the lungs. When you carry the deoxygenated blood contains partial pressure of 40 because that is deoxygenated blood. The oxygen level will be less, whereas carbon dioxide will be more. So there is an exchange of gases from higher partial pressure to lower partial pressure. Now the blood that is coming after the oxygenation is the oxygenated blood. After the exchange of gases, now the blood which is coming is oxygenated blood. This oxygenated blood is carried by pulmonary vein and opens into left heart. After it opens into left heart, from the left heart, aorta will take this blood, that is oxygenated blood, to where? To the tissue. In the tissue, the level of oxygen is less, the level of carbon dioxide is more. Again, there is an exchange takes place between the tissue and the blood that is coming from the aorta and arteries. Then, as they get exchanged, now this deoxygenated blood will turn into deoxygenated blood because there is an exchange of gas happened now here. Now the blood which is coming out of the tissue is deoxygenated blood. This is carried by vena cavas and then again open into right heart. This keeps on continue and this happens due to a difference in the partial pressure of oxygen and carbon dioxide at different site. High oxygen content is found in alveoli, then the low oxygen content is found in the tissue which is being used in the deoxygenated blood. In the oxygenated blood, you have high partial pressure of oxygen. In the deoxygenated blood, you have high partial pressure of carbon dioxide. Is this point clear to all? Any difficulties here? Do let me know. Any difficulties to anyone? I'll give you 1 minute to everybody to revise quickly. 1 minute each. Listen, my dear students, these numbers are very important. How do they give you, they give this kind of image, something like this, and they'll leave the space, the partial pressure of oxygen in the alveoli. So this is A, mark it as A. So they'll ask you, what about A? What is the partial pressure? It's easy to remember. First thing is, it is 40, 45, 45, 40. Here deoxygenate 40, 45. Here exactly opposite, right? You have to double this 40 you have to write it here, and then this double or more than that you have to write it. You need to remember it like this. This numbers is very, very important that you need to remember. I'll give you 1 minute to revise. Each and everybody will revise before I move to the next. Supra, no doubts? Well, good.
Ma'am,
Yeah, tell me.
beside iota it is 95 or 45.
95, yeah. In aorta and artery, the blood moving is oxygenated blood. This pink color is all oxygenated blood, right? In the oxygenated blood, your oxygen level is high than the carbon dioxide level. So the movement of oxygen from high concentration to low concentration, there is an exchange that happens at this level. Now the blood which is coming out will be deoxygenated. Now this will be deoxygenated. Yeah, I'll show you the slide. Any Any doubts? I think that was Sanjana. Who was it?
No, ma'am. Sanika.
Sanika, any doubts?
No, ma'am. No doubts.
Others, any doubts?
No, ma'am.
It's all clear. Can I move to the next? Okay, let me show that diagram. This is given in your NCRT book. This is given in your NCRT book, this diagram. Yes, done. Yes, is it done? How many students? Let me check. 54. See, I want each and everybody to join at least 2-3 minutes before. Okay. All the 54 students, is it clear? Okay, this table is also given in an NCRT book. You need to remember this table. This table is also given in your NCRT book. You need to remember this table. Okay, which you have already written. We can just go through these two things. Exchange of gases occurs. Gases exchange between air and the blood. Gases diffuse from region of higher partial pressure towards the lower partial pressure. Oxygen diffuses from alveoli into the blood. Carbon dioxide diffuses from blood into alveoli. You can just go through these 2 points quickly. Any doubts with this slide, you can question me. Yes, you can take the notes of this slide. I hope you understood, Yash. Did you understood the exchange between the alveoli, blood and tissue? All clear? Very good. Larissa is there in the class today? Larissa, are you there?
Ma'am, I think she's for coaching.
She's in the coaching. Okay, fine. Thank you. Okay, everybody done with this slide? Can we move to the next? Okay, this is what same thing what I have explained just now. So next, let's go to the transport of. We have exchanged the gas now, but exchanging the gas, we need somebody to carry. Which slide? This slide.
Alveoli and
Which
blood.
one? This you have already done, no? Yeah.
To write this,
Or you can take a screenshot, but I hope you understood what is written there.
Okay, ma'am, done.
Done? Okay. So now we know there is exchange, but we need somebody to carry that to the different. There's a movement, right? For example, the oxygen is moving from here to here, from here to here. Who is taking that? Who is carrying the oxygen? Tell me. Blood is carrying, right? In the blood, there are so many components. Do you think each and every component is carrying the oxygen? Do you think in the blood, each and every, there's so many things in the blood we have studied? Yes, hemoglobin, RBC, only those cells carry the oxygen. So now we need to study about this. We have already studied about the RBCs in the previous class. Just with the revision, we'll do transport of exchange of gases. Blood is a medium. You all know this. Oxygen is transported 97%. You know what is plasma? 97% by RBC. Important question. 3% by plasma. Important question. They'll ask you what are the ways that hemoglobin is oxygen is transported. One is by RBC and by plasma. But most importantly, 97% is RBC. What's the structure? Hemoglobin is a tetramer. Tetra means 4 polypeptide chain. It has 4. 1, 2 alpha and 2 beta. 2 alpha and 2 beta. How many? 4 polypeptide chain. You can see beta chain, alpha chain, alpha chain. So if this is alpha, and this will be beta. So it is 4 polypeptide chain. One hemoglobin can bind to 4 oxygen molecule, my dear students. So one hemoglobin, very important question this is. One hemoglobin can bind to how many oxygen molecule? MCQ question. MCQ questions. Okay. One hemoglobin can bind to 4 oxygen molecule. Hemoglobin is a protein composed of 4 polypeptide chain and 4 organic heme group. You can see this heme group. Each polypeptide chain has one heme group. Iron atom at the center of each. Can you see the iron atom at the center of heme group? Can you see the iron atom here? Hemoglobin loads up with oxygen in the lungs, forming oxyhemoglobin. As blood passes to the capillaries, some of oxyhemoglobin release and become deoxyhemoglobin. That is the how the blood gives the hemoglobin to the other body parts, right? So what does it say? This is a let me draw it again for you. Listen to this. This is alpha chain and this is beta chain. This is beta, this is beta, this is alpha, this is alpha. How many polypeptide chain? 4 polypeptide chain. Each of this is having a group that is called heme group. Each of this is having a group that is called heme group. In that heme group, at the center, there is a molecule at the center that is iron. What is this? Heme. What is that? Heme. And then you have iron at the center. Each iron will bind to one oxygen molecule. Each iron will bind to one oxygen molecule. So totally how many oxygen molecule a hemoglobin can bind? Are you all there? So totally how many oxygen molecule a hemoglobin can bind? 4. Why 4? Because it has 4 polypeptide. Why 4 polypeptide? Because it has 4 heme. Each heme is carrying a 4 iron molecule. So each iron molecule will bind to 1 oxygen. So totally the hemoglobin will bind to 4 oxygen molecule. Is it point clear? Very important MCQ. Okay, write down this quickly. Done? Any doubts to anybody there? Hemoglobin binds to oxygen to form oxyhemoglobin. So if it is 4 oxygen molecule, then it is V4 and O8. This is completely saturated hemoglobin. Completely saturated. Understood? Any difficulties there?
Ma'am, please go
You
back
can
to the
write down
previous
this.
slide.
Just to the last line.
Done, ma'am.
Oxygen combines with hemoglobin in the alveoli. In the alveoli, in the blood vessels. Yes, in the lungs only, but blood. I have told you, I have shown you the diagram where the lungs are totally in completely in contact with totally and completely in contact with lungs, right? They are occupied with the lungs. They are covered with the baton with the blood vessels. Alveoli are enrichedly with blood vessels. Okay, next slide. Oxygen transported from the lungs to tissue. Oxygen is transported in two forms, in the plasma form and in the hemoglobin form. Each hemoglobin can maximum 4 molecules of oxygen. This we have studied. This is how the oxygen, see, you can see the oxygen molecules binding with the oxygen is getting inside the blood vessel by simple diffusion. By simple diffusion. Go through this slide. If you have missed something, you can write it down. You can see how the binding is happening, hemoglobin molecules, how the oxygen will come and bind to the hemoglobin molecule. Done? I hope it's getting clear. I hope everybody is getting clear with the concept. If still anybody has any doubts, your doubts are welcomed. But clear your doubts. Do not carry them. Any doubts to anybody still? Any doubts to anyone still? All clear? Very good. Shifa says it's clear. Okay, fine. Good. So we'll stop the class here. Next, we'll be starting with oxygen dissociation curve, which is very important again. We'll do it in next class. Before I move, let us quickly take a revision of today's class. Okay. Everybody on the chat box, before we move, we'll take a quick revision of today's content.
Ma'am, we have to write this based on the screen.
No, do not write. We'll discuss in the next class. Okay. Okay. First question. Which are the two ways of carriers of oxygen? Two waves of carriers of oxygen. Hmm? Two waves to the carriers of oxygen. Nobody? Or I'm not receiving any? Are you all there? Hello? Hello? Yes. Who is this? Yes, plasma and hemoglobin. Okay, very good. Next question. The exchange that happen between the gases and the tissue is by what? The exchange that happen between the gas and the tissue is by what? Partial pressure by simple diffusion is the right answer. Very good. Partial pressure by simple diffusion. Very good. Next. What do you understand by tidal volume? What do you understand by tidal volume? The volume of air which is normally inhaled and exhaled. Very good. The amount of oxygen inhaled during inhaled and exhaled Sakshi. Inhaled and exhaled. Okay, both the terms should be there, Sakshi. Next. Hemoglobin is made up of how many polypeptide? 4. Very nice. Which is that molecule or a metal that is present in the hemoglobin? This is the last question. Very good. Iron. Is it clear for today's class, my dear students? Is it clear to everyone? I think most of them have not had their lunch. So I'll wind up the class here. So see you all in the next class next week. Until then, Happy weekend. Study, keep learning, and enjoy your time too. Okay? Bye bye, everyone, and start reading for the upcoming test. The new people, okay, the new students. Today there will be a revision class, right? There will be revision class at 8 to
Yes,
9.
ma'am.
Cockroach. You can come and join me there today, 8 to 9. Rest all can have a good time, but keep studying. Bye bye, everyone. Take care.
Thank you, ma'am. Excuse me, ma'am.
Bye. Yes, who is this?
Ma'am, it's Sanika.
Sanika. Yeah, tell
For
me.
the new students, you'll be taking the revision class now.
Yes, yes.
So today you'll be doing the cockroach part.
Yes, I'll be doing the cockroach part.
Okay, ma'am. Thank you.
That's what you wanted to ask?
Yes, ma'am, that's it.
Oh, yeah. Chalo, take care, everyone. Bye. You're welcome. Bye bye.